Arithmetic sequences and series. An arithmetic sequence is a sequence where the difference between consecutive terms is constant, and that difference is called the common difference. So in these next two examples, we need to decide whether the sequence is arithmetic, and if so, find the common difference and then write the next term. So from 4 to 7, we added 3, 7 to 10, we add 3, 10 to 13, add 3, and 13 to 16, add 3. So that means our common difference is going to be 3 because we keep adding 3. So to get our next term, we want to add 3, which is going to be 19. So here's our common difference, and here is our next term. I want you to go ahead and pause, try example 2, and check back with me when you're finished. When you look at example 2, from our terms, we're adding 3, then 6, then 12, then 24. Because this is not a common difference, we say that it is not arithmetic. You cannot find a common difference because there isn't one, and we can't write what the next term is going to be. Now here's a formula that we're given to help us find the equation for the nth term. This is given to us on the SOL formula sheet, so you don't need to memorize it, you just need to know when and how to use it. A sub n represents the nth term. A sub 1 represents the first term. N represents which term number. And then D represents the common difference. In example 3 and 4, we want to write a formula for the nth term, then find A sub 21. So this is the general formula we're given. We need to write a rule for A sub n, so that's going to stay. And then we also want to be able to substitute in whichever term number we're looking for. So A sub n and n will stay as variables. So we really need to find A sub 1 and D, substitute those numbers in, and then simplify this formula. So for example 3, it gives us the common difference and the first term. So we're going to go ahead and substitute in those values, keeping A sub n and n. And then we just need to simplify the right side so that we have a clean formula to work with. We're going to distribute this 4. And then we're going to combine like terms. So we have A sub n is equal to 4n minus 7. This is going to be our formula for the nth term. Then part 2 asks us to find A sub 21. So we want to find what is the 21st term in this sequence. So we substitute 21 in for n from our formula in part 1, and then you will find that A sub 21 is equal to 77. I want you to try example 4 and check back with me when you're finished. You might have to do a little extra work because you're not given the common difference in A sub 1, but I think you'll be able to find it on your own. So hopefully you identified the first term in the sequence as 2, or A sub 1, and then as you find the common difference, you should get that it's equal to negative 2. So we're going to substitute those in to our general equation, keeping A sub n and n as variables. And again, simplify the right side. So our formula should be A sub n equals negative 2n plus 4. Then when we're looking for A sub 21, substitute 21 for the value of n, and our 21st term in this sequence will be negative 38. Now example 5 gives us the same set of directions to write a formula for the nth term and find A sub 21. The only problem is this one's a little trickier because they give us two terms. The 4th term is 16 and the 13th term is 43. So we actually need to find the common difference and the first term, A sub 1. So in order to do this, to find the common difference first, I want you to think about slope. So we're going to take the actual terms, 16 and 43, and subtract them. Then you're going to take the term numbers and subtract those on the bottom. Now keep them in the same order, and the way you can remember which one goes where is the term number is a little lower. So those are going to go on the bottom. This is going to give us negative 27 on the top, negative 9 on the bottom. So our common difference is actually going to be positive 3. So let's hold on to this value. Now we have to go and find a sub 1. So we're actually going to use our general formula, a sub n is equal to a sub 1 plus n minus 1 times d, to find it. So when we look at the values that we know, we actually found d to be 3. A sub 1 is what we're looking for, so that needs to stay as a variable. Now, a sub n and n are both variables we need to replace. We are given two terms to begin with, and it doesn't matter which one you pick, but this is what we're going to use. I'm going to take the first one. The fourth term, n, is equal to 16, which represents our a sub n. So now let's actually substitute these values in, and so we see what we have. So we have 16 equals a sub 1 plus 4 minus 1 times 3. So now we're going to solve this equation for a sub 1. So 16 equals a sub 1 plus 3 times 3. 16 equals a sub 1 plus 9. And then 7 equals a sub 1. So these are the two pieces of information we need to even start finding the formula for the nth term. So now we can start where we did for example 3 and 4. We're going to take our general formula and then substitute in our common difference and a sub 1. So a sub 1 is 7, our common difference is 3, and then again we're going to simplify the right side. So we get 7 plus 3n minus 3. Simplify, a sub n is equal to 3n plus 4. This is our formula for the nth term, and again, finding a sub 21, the 21st term, substitute in 21 for n, and we're going to get a sub 21 is equal to 67. So this part is the same as we did in example 3 and 4. It's just finding the information for the common difference in first term takes a little bit more work. Now I want you guys to pause, try example 6, just like we did example 5, and check back with me when you're finished. Hopefully you found that the common difference was 4, a sub 1 was negative 5, the formula for the nth term, a sub n equals 4n minus 9, and then a sub 21 equals 75. If that's not what you got, pause, check your work with mine, and see where you might have made a mistake. An arithmetic series is the sum of all of the terms in an arithmetic sequence from a certain term to a certain term. So remember, an arithmetic series is the sum of all of the terms in an arithmetic sequence. So don't forget about our sigma notation that tells us we're going to be adding all the terms from the first to whatever number is up on top, and then we have our general formula for the nth term. So instead of finding every single term from 1 to n and then adding all those up together, this formula gives us a shortcut. This is on the SOL formula sheet, so we just need to know how to use it properly. So in example number 7, it asks us to find the formula for the nth term of the arithmetic series, then answer part B. So we need to start by finding the formula for the nth term. A sub 1 is the first term, and then we need to find the common difference, which happens to be 2. So our common difference is equal to 2. So let's start with that general formula and then substitute in our values that we know. And then we're going to go ahead and simplify. And then our formula for the nth term is going to be a sub n equals 2n minus 1. Now as we move on to part B, where we need to write the formula to find the sum of the first 11 terms and then find the actual sum, I'm not going to use the summation part. I'm actually going to use the part that's on your SOL formula sheet so that it stays familiar. So we're going to start with the formula. The sum of the first n terms is equal to n over 2 times a sub 1 plus a sub n. So we are looking for the sum of the first 11 terms. So we're going to substitute in 11 for n. Our first term, was 1. And then we don't know what our last term is. But because we have the formula for the nth term, we're going to use that, but substitute in 11 for our n, which would be our 11th term. Then when you simplify, the sum of the first 11 terms is going to be equal to 121. I want you to try example 8 on your own and then check back with me when you're finished. Hopefully you found that the formula for the nth term was a sub n equals 5n minus 2, and the sum of the first 11 terms is equal to 308. That's it for this video on arithmetic sequences and series.